Oh, there we go. Oh, it's a bit of a bad picture, but yes, we are from a fire service down under, and we like to think that the world looks this way for us. And just to give you a bit of an idea on how we are set up, we have 8 states and territories in Australia. They each have a metropolitan and regional fire service. So we are a metro fire service. We have just over 1,000 full-time and part-time staff, and they're at 36 stations located around South Australia itself. We also have a volunteer brigade within the state, which looks after the bushfire risk and the other towns that we are in. The population of South Australia is about 1.7 million people, most of which live along the coast. And Adelaide, the capital city, has a population of 1.3 million. We used AFFF from about 1970s-ish through to 2006. It was used sparingly. We didn't tend to use it that much. We then used a foam that contained PFOA up to 2014 when it was completely removed from service, and we replaced it with fluorine-free foam. We now have also replaced our fire extinguishers all with fluorine-free fire extinguishers.
Crystal and myself are in a really fortunate position where we inherited a problem with the help of our chief officer, who was firmly committed to this precautionary principle where we didn't know much about what PFOS, PFOA, PFHXS, the whole PFAS suite was back in 2018. And that commitment to not assuming that no evidence meant that there was no problem saw us go about determining where are these risks, what are the exposure pathways, which ones are occupational, are there any that are non-occupational. So we were quite fortunate that in Australia, the National Environmental Management Plan for PFAS was released, which gave us some guidelines around soil and water criteria. And we derived our own risk assessment based on a bit of a hybrid. We live in our fire stations, they're a home away from home. That's been the philosophy for forever in fire services. So people go about planting vegetable gardens, fruit trees, and unfortunately even rearing chickens on some sites. So deriving these figures up to 20,000 micrograms per kilogram as trigger points and versing that to what we had at a particular site from 135 with some remediation down to less than 40 now, we've got significantly less risk than what we initially thought. We were really fortunate to develop a great collaborative relationship with GHD, who are an engineering firm, and they derived some trigger points for our fire appliances. In the meantime, adopting that precautionary principle, Crystal, myself, and also the Firefighters Union in South Australia, we agreed on some really conservative trigger points, which were the drinking water and recreational guidelines in Australia, which I think was the right thing to do at the time. We then had another potential exposure pathway, although the literature said quite small, we weren't certain. So we did some assays on dust in our fire station, based that on an Australian standard for collection of dust with the supervision of a professor who's a dust expert, and fortunately came back with a PFAS recording less than 100 times of the risk assessment, and therefore suggesting that the risk was not of concern for people for any period of time at the site. So go into a little bit more detail on some of the specifics, but keeping in mind that we had a very much a work health and safety approach to this, and keeping up to date information and consulting with our workforce is an important aspect moving forward.
So we started a voluntary blood testing program for our current and retired firefighters. We started that in April 2018, and we had over 850 serum results come back, which included a few family members. And we used a PFAS suite that detected 28 different PFAS, including C4, C6, C8, and C10, among others. From this suite, we detected 5 main PFAS in our firefighters' blood. So PFOS, PFOA, PFHXS, PFHPA, and PFNA. And this was consistent with the chemical makeup of AFFF that we had been using over the time period. PFOS was the most prevalent in our staff. We actually had really low PFOA levels. And we're looking to undertake another round of voluntary blood testing this year so we can see what happens when we stop the exposure to see how quickly those levels drop in our firefighters. Because we had over 850 blood test results, we could then look at developing some occupational PFOS levels in our staff because PFOS was our most prevalent found. And they were actually quite different between males and females. Now, we do have a much smaller sample size of females. However, the full-time operational male, we derived an average of 14.5 nanograms per mil of PFOS in blood, and full-time operational female 3.45. Our retained staff are our part-time staff, and they were very similar in blood levels of PFOS average. And then we looked at our MFS retirees, which were only males, and that gave us an average of 12. And we tested 2 staff members before they had any occupational exposure in the fire service. So this was before their recruit course, and they gave us levels of 4 for PFOS. We had a couple of anomalies in our readings. The highest blood level that we had was the top table there that you can see. This was a firefighter that was retired. He'd spent 35 years in the job. He worked his way up from firefighter through to commander. He ended up in charge of our logistics and engineering section and was in charge of changeover of foam and restocking of foam. When our doctor saw the result, they thought, oh my goodness, what has he been doing? Has he been drinking this foam concentrate? But then they looked further and he actually has psoriasis. And they then thought, okay, well, maybe the skin is more prone to absorb everything because of his psoriasis. He probably had quite a few splashes of concentrate onto his skin in the changeover. And that is probably why he's derived a level that high. The other level we had was the highest level in our operational firefighters, and we'll talk about his particular station later. He has a hobby of bodybuilding and so has quite a high level or a low level of fat in his body. We found that PFAS binds mainly to protein, not to fat, and so it seemed to accumulate and stay in his body longer than anybody else's. He also had an increased fish and egg consumption due to his hobby, so was probably consuming more of contaminated produce than anybody else. We then saw that our staff had a really high level of anxiety, and we contracted a doctor in to talk to those staff and look at the research and develop individual treatment plans to look at reducing the levels of PFAS in their blood. Now, this first graph we're looking at are firefighters who participated in this reduction program, and their starting PFAS was less than 250 nanograms per mil. There was a few different options that the doctor come up with. There was plasma and or blood donation, and there was also a drug that had some research papers on it called cholestyramine. And so she just worked with them whether they didn't want to do blood and plasma donation, whether they didn't want to take medication or whatever they wanted to do, and she developed individual treatment plans for all of them. We had some firefighters that had a starting blood PFAS of greater than 250 nanograms per mil, so I just had to separate the graphs out. So this is just their graph showing those that participated in the PFAS reduction program. And as I said, we hope to do a second round of blood testing this year. So then we will be able to look at the people that didn't do any treatment and see how their blood levels dropped. So if we head back to our anomalies that we looked at the start, the bodybuilder that had the starting PFOS level of 600, he decided to go down a treatment route. So we stopped his exposure 18 months ago, and he started treatment 6 months ago. And he's been able to drop his PFOS level from 600 to 39, which is a fantastic drop for him. He also dropped in the other 4 PFAS that were picked up in his body. So we're just going to look at one station in particular. So So this is called the Lefevre Peninsula in South Australia. So the beach or the ocean is on one side and there's a river on the other side. This is quite an industrial area. The staff at our station in here we called them a cluster station. They had quite a high level of PFAS in their blood, well above any other station. The soil's made up of sand, so really permeable, allowing everything to pass straight through, not stick around in the soil. The groundwater was also very shallow, so only about 2 feet below the surface. And this river here has quite a big dolphin population, and they had done a study on PFAS levels in the dolphins, and they found that the levels of PFAS in their livers were the second highest in the world. So here's our little station up here. And you can see by all these cylindrical tanks that they are quite surrounded by fuel farms. The groundwater does go in this direction, so from bottom of screen to top. So we don't have a great fuel supply in our state. We have at least one fuel tanker coming in every 48 hours to deliver fuel. And all of these fuel farms still have AFFF foam that they use and on site.
About 3 minutes remaining.
Thank you. So this is the level of PFAS that we found in our staff at this station. So you can see quite a bit higher than the other firefighters.
I did notice a pop-up on the screen, a question about looking at the water supply at site. And I'll go into a bit more detail of the investigations that we did now. So we looked into exposure pathways that were initially the fire appliance, the gallantry, which is our fireboat. And you can look through this graph here and you can see in blue the actual exposure pathway, actual versus the risk assessed criteria. And the conclusion that we drew, that was very little occupational exposure other than the gallantry, which proved to be an anomaly. When the water supply for the foam pump was serviced, it released neat PFAS into the aluminium area, which was containing welds, and separate areas which has continued to release PFAS over a period of time. But the egg yolk graph is the one that's most important, and we've determined that that peak exposure at the large site was due to this egg yolk. And to put that into context, it was somewhere up around the 1 million time in excess of the food standard trigger point for poultry.
And we did test the mains water, or the drinking water, on site, and we have different drinking water in Australia to the US, and there was no PFAS detected at all in their drinking water.
That led us on to this potential that dust may be impacting the staff. And as you can see from the graph and mentioned before, the guidelines are 100 times or more in excess of the risk actual. And if you have a quick look at these levels here, we've assessed every single one of our sites, and we had no site that was occupied by firefighters permanently that was anywhere remotely close to the National Environmental Management Plan for commercial industrial sites.
1 minute remaining.
Looking into our fire appliance exposure pathway, assessed every single one of our appliances that contain water, decontaminated them to the drinking water guidelines or recreational, which our consulting engineers thought was perhaps unachievable. We did achieve that, and we've now got these guidance values based on risk assessments that are far in excess of our initial agreed trigger points. So moving forward, we're still providing people with any mental health assistance that's required. Some of our staff that haven't yet come below the occupational average are continuing the reduction program. Thanks to the government and a commitment to some continued funding, we will offer a blood serum follow-up in 2021, hopefully quite soon. What that will do, that'll allow us to assess that we've actually broken these exposure pathways. And really fortunately, just yesterday received information that Air Services and the University of Queensland in Australia have just released a paper on PFAS, which is longitudinal study into exposure of their firefighters. And we'll share that link as a hyperlink in the notes so that people that are interested have a bit of a look. But it's quite pleasing, the information available.
I'll put it in the chat screen.
Sorry if we went a little over time, but compressing 3 years nearly of work into that period is it's quite a challenge. Thanks very much for the opportunity, though, and I'm hopeful that, if nothing else, some of those communities that are feeling a little disenfranchised or disempowered in America and other places may be able to pick up on the fact that there is something that can be done to eliminate PFAS from serum. And although it's not a controlled study, it's retrospective at the moment, we're looking for some kind of research link, if some funding was to become available, to put some literature together and potentially have it published.
It's great. It's a wonderful study. Thank you for sharing it. And I think it would be lovely to see that level of being proactive, everywhere, right?
That's right.
If I understood correctly, for the past 10 years, you have been using fluorine-free foams. Do these meet the necessary firefighting performance? Are you aware of the toxicity studies of fluorine-free foams and whether they do indeed show lower toxicities in AFFFs?
I might grab the toxicity part of that. Sean can answer the other one, but if you look at the environmental toxicity, a lot of fluorine-free foams are worse than AFFF foams, but really we don't use them that much.
No, we don't.
We went through and we looked at some operational guidelines to make sure our firefighters are protected when using foam, but we're probably a very low user, like extremely low. I don't even know, we probably use foam once or twice in that time period.
Well, I think we use it far less now too, being aware of this environmental impact. It was something that was used on running fuel fires for vehicles, etc., up until we gained an understanding of what AFFF was doing in the environment and potentially to our people. So I think to answer that question, is there research to suggest that non-fluorine containing foams can perform as well as fluorine containing foams? I guess there's two sides to that argument, and there's some really interesting advice out of Queensland in South Australia from the EPA, where perhaps we need to, when we can, reconsider how we approach firefighting. Now, in an event that a 747 has an engine on fire, perhaps AFFF is the only thing that will work in that event. But when we're on land, near rivers, perhaps we don't need to use fluorine, and the damage that's, or foam of any sort for that matter, because the damage that's done by allowing the fuel to burn out may be far less. It really is a very interesting question.
Hopefully that answers it a little bit.
I think so. I had a quick question, and I know we're going long on time, but what is involved in the treatment? You referred to, these firefighters going through treatment to lower the levels in their blood. What does that mean that they go through treatment? And maybe you said this.
So no, that's okay. They all developed individual treatment plans with the doctor, and
okay.
it all ranged from things like they might have donated blood very frequently. They might have donated plasma frequently, or they might have donated both, or they might have taken the drug cholestyramine, or they might have done all three. We found that those sort of three methods were the ones that had some research behind them.
Okay.
And that's, they're the plans that doctor went down.
Okay, great. All right, well, thank you for sticking around. Go ahead,
cholestyramine is a cholesterol reducing drug that's readily available. It's been available for years, tens of years.
Interesting. Okay, thank you for sticking around and answering questions. I really appreciate it.